Hello students, welcome back to Future Foundation. Students, in today's class of vector, we will learn two fundamental theorems and then we will see some applications of cross product. So let's begin. Students, write down the heading fundamental theorem. So first fundamental theorem is fundamental theorem in plane. So in this we will write let A vector and B vector be two non-collinear vectors, then any vector R in the plane of A and B means A vector, B vector and R vector are coplanar vector. Any vector R can in the plane of A and B can be represented as a linear combination of other two, right? That is R vector is equal to XA vector plus YB vector. So what I'm saying, let's say this is XA vector and this is YB vector, then this is the parallelogram and diagonal of parallelogram is nothing but R vector, which is XA vector plus YB vector, right? So this is fundamental theorem of plane. Now next theorem is fundamental theorem of space or fundamental theorem in space. Second one is fundamental theorem in space. So in this we will write let A vector, B vector and C vector be three non-coplanar vectors. Then any vector R in space can be represented as a linear combination of other three. That is R vector is equal to XA vector plus YB vector plus ZC vector, or what I'm saying, let us understand by drawing a parallelepiped. So let's say these three vectors are non-coplanar. This is XA vector, this is YB vector and this is ZC vector. So resultant of all these three will be this R vector. So this is fundamental theorem in space. Now let us write a question. An arc AC of a circle with center 0, 0 and radius 1 subtends 90 degree at origin. A point B divides AC in the ratio 1:2, right? Now express vector C in terms of E vector and B vector, where A vector, B vector are the position vector of point A and point B, and C vector is a position vector of C, right? So I have not written this, but you can understand, or you can write in your notebook. So what I have written in the question, an arc AC of a circle, right? So let's say this is an arc AC, right? And this arc subtends right angle or 90 degree at origin. Okay, origin is 0, 0. A point B divides AC in the ratio 1:2, means this is 1 and this is 2. What does it mean? It means if this angle is 90 degree, then this will be 30 degree and this will be 60 degree, right? Okay, and position vector of A is A vector, position vector of B is B vector, position vector of C is C vector, right? Now what we have to do? We have to express vector C in terms of A vector and B vector. So let's say uh, also we can see A vector, B vector, C vector are coplanar vectors. Here A vector, B vector and C vector are coplanar vectors. So any vector can be represented as a linear combination of other two. So C vector can be written as XA vector plus YB vector, right? Now we have to determine X and Y to determine vector C completely. So now what we will do, we will take a dot product of vector A both sides, right? Taking dot product both sides with A vector. You can take dot product both sides with any vector of A, B and C. I am taking right now with A vector, right? You can take with B vector or with C vector as well. So now if I do this, then it will become E vector dot C vector is equal to X E vector dot A vector plus Y vector Y B vector dot A vector, right? As A dot the dot product is commutative, you can write A dot B or B dot A, right? So it doesn't matter. So A dot C means AC cos theta, and theta is the angle between vector A and vector C, and I can see in figure angle between A and C is 90 degree. So this will be AC cos 90 is equal to X mod A square plus Y mod B mod A cos theta, and theta is the angle between A and P. So this is cos 30 degree, right? So cos 90 is 0. So this will be 0 is equal to magnitude of A vector, right? Magnitude of A vector is 1 because radius is 1. This is 1, this is 1, this is 1 because center is origin. So x plus y cos 13, which is root 3 by 2. Okay, or you can say 2x plus root 3y is equal to 0. So this is 1. Now again taking dot product with b vector both sides. If I do this, then it will become b dot c is equal to x a dot b plus y b dot b. Okay, so BC cos of angle between B and C. So this is 60. So this will become cos 60 is equal to x E B cos 30 again plus y mod b square. So cos 60 is 1 by 2 is equal to x to root 3 by 2 plus y. Okay, so this will become root 3x plus 2y is equal to. So next question is, if A vector, B vector and C vector are coplanar vectors, then prove that determinant of A vector, B vector, C vector, E dot A, E dot B, E dot C, B dot A, B dot B, B dot C is equal to 0. Right? Again we will use fundamental theorem in plane, because A vector, B vector, C vector are coplanar vectors. So as A, B, C are coplanar, so according to question, C vector can be written as XA vector plus YB vector. Again I am telling, I am taking C vector as XA vector plus YB vector. You can take any one of these three, or you can write A vector is equal to XB vector plus YC vector, or B vector is equal to XA vector plus YC vector, right? Now from LHS, E vector, B vector, C vector is XA vector plus YB vector. E dot A E dot B, E dot xc vector plus by v vector, P dot A, P dot B, P dot xc vector plus by v vector, or E vector P vector xc vector plus yv vector E dot A, E dot B, x E dot A plus y E dot B, P dot A, P dot B, x P dot A plus y P dot B. Okay, now we will use operation. Change in row 3. Change in column 3, and change is C3 minus xc1 minus yc2. Okay, so this will become, if I am writing column wise, A vector A dot A, P dot A, P A dot B, P dot B, 0 0 0, and it will become 0, which is RHS of proving. So hence proved. Okay, now let us come to next topic, that is applications of cross product. Heading applications of cross product. So in this we will write first, by using cross product we can find perpendicular distance. Now perpendicular distance, first perpendicular distance of a point from a line. Okay, so let's say this is given line and this is a given point. Point having position vector p vector, and line is passing through given point A having position vector A and is parallel to B vector. So equation of line can be written as R vector is equal to E vector plus lambda times B vector. We need to find this perpendicular distance, say PM, and PM is D. If I join E to P, then this will become AP vector. So D will be, if a AP vector is making or inclined angle theta with the given line, so D will become mod AP sine theta, right? And this sine theta is nothing but mod of cross product of AP vector cross P vector on mod of AP vector into mod of P vector, right? So AP vector, mod of AP vector and mod of AP vector will cancel out. So this D is nothing but mod of AP vector, which is P vector minus A vector cross P vector on mod of P vector. So this is required distance. Now second one is perpendicular distance between two parallel lines. We will make a figure. Let's say these are two parallel lines parallel to some vector v. So let's say equation of the above line is r vector is equal to a vector plus lambda times b vector, where a vector is the position vector of point A through which a line is passing, and lower line having equation r vector is equal to some c vector plus lambda times b vector. Again, c vector is the position vector of point C through which line is passing, and I need to find this AM. So again we will join A with C and it will become CA vector. So if this CA vector is making an angle theta or inclined with angle theta with the lower line, so AM, which is D, will become mod of CA vector sine theta. On the same line we can write this D as mod of CA vector times mod of CA vector cross B vector upon modulus of CA vector into B vector, right? CA vector, mod of CA vector cancel out. So D will become mod of C minus A cross B by mod of B. Okay. Now this is required distance between, or required perpendicular distance between two parallel lines. Now let us take a question. Question is, find distance between r vector is equal to 1, 2, minus 4 plus lambda times 2, 3, 6, 2, 3, 6, and r vector is equal to 3, 3, minus 5 plus mu times 2, 3, 6. Okay, so sorry, in the above figure this is same mu. Now if we see question, so see lambda times this and mu times this, what they represent, they represent the lines are parallel. Okay, because these two lines are parallel to the same line or same vector. So right here given lines are parallel, so D will be mod of C minus A. This represent A vector, this represent C vector, right? So C minus A, which is 3 minus 1 2, 3 minus 2 1, minus 5 plus 4 minus 1, cross B vector. This is B, this is B vector, right? Cross B 2, 3, 6 upon mod of 2, 3, 6. So now we have to find 2, 1 minus 1 cross 2, 3, 6 using determinant method. I, J, K, 2, 1 minus 1 2, 3, 6. So I times 6 plus 3 minus j times 12 plus 2 plus k times 6 minus 2. So this will be 9i cap minus 14j cap plus 4k cap. So d will become mod of 9 minus 14 4 on mod of 2 3 6 or root over 81 plus 196 plus 16 on root over 4 plus 9 plus 36. So this will become root over 293 upon root over 49, that is 7 units. This is T. Okay. Now make some note. It's time to note. Note. If question is demanding the distance between two lines, then always check. What we have to check? First, lines are parallel or not. If lines are parallel, then proceed as above, जैसा हमने लास्ट क्वेश्चन में किया है. And B, if lines are not parallel, then check lines are intersecting or not. If lines are intersecting, then distance between them is 0, because lines are intersecting, they meet each other. And okay, this is B, this is 2, and for 2 this is A and B. If lines are not intersecting, they are skew lines. Skew lines are the lines which are neither intersecting nor parallel. So next question will become, if lines are skew lines, then how we can find the distance between them? So we will learn this concept in next class. So students, for this class, this is all about. Let's meet in next class. Till then, bye bye and take care.